Good morning once again. This 10th session of the faculty development program of the 6-day program is starting by now. Speaker is joining in a moment. Meanwhile, I am inducted to read his profile. So after much deliberate attempts, we could able to connect with Dr. Mariappan for delivering a session today. So Marappan Muthakumar is Nanda Engineering College, who is holding the position of professor and head of the Department of Mechanical Engineering, and with his basic degree in the bachelor's from Maharaja Engineering College, Avinashi, in year 1999. He further got the degree of Masters in Engineering Design from Maharaja Engineering College itself in 2004. And in 2016, he completed his doctoral degree in PhD College of Technology, Coimbatore, and Anna University. He holds the total teaching experience up to 24 years, and presently his position is HOD cum professor in Nanda Engineering College. Earlier to his academic career, he also had a short stint of industry as an assistant production engineer in Agni Steels, Erode. To tell about his research and grant received from various agencies, starting from the innovative scheme of MSME to the tune of 15 lakhs in year 2023-24, under artificial intelligence-based fuel cell-powered electric vehicle, and other grant he received is from AICTE Research Promotion Scheme in the year of 2017 to the tune of 25 lakhs. And in the Nanda Engineering College supported scheme, he has set up a fuel cell electric vehicle and battery thermal management system for it. He holds 5 patents, out of which are entirely related to this career in the fuel cell itself. Some of them are taper flow field and 3-to-1 serpentine flow field for fuel cells, novel diagonal cells for fuel cells, porous carbon inserts again for the fuel cell, proton exchange membrane, and hexagonal serpentine design for the fuel cell. And he has been also awarded copyrights for 2 academic works, one in the fuel cell and another in the third subject of dynamics of machinery laboratory. Apart from the patents and other recognitions in the research field, he has been consistently awarded as a best faculty and best researcher in many forums, and he has got one such award from IEI Society, and he has also got an award regarding the Centum Producer Award in the academic records. To tell about its publications, the list goes up to about 50 numbers, and he has been majorly authoring the papers related to the sustainability related factors in the form of the natural fiber composites, and recently, after his attempt into the fuel cell related domain, he has consistently got many publications regarding the fuel cells, and many of the publications of him are cited again and again, and he has got the reputation of being one of the main reference behind the fuel cell related research in India. And to tell about the book publications, he has got 2 books published under his name, one in the Stranger Nature in the name of effects of different membranes on the performance of PEM fuel cell. Another is the applications of artificial intelligence on fuel cells. Both are on the Springer. And he has attended many conferences, and the conferences presentations of him are more than 30 numbers. And he has presented papers in all the occasions. And he has independently published a book titled Heritage of Tamil. Apart from the regular core academic work, he has also shown his interest on the Tamil, and I think it is catering to the need of the Anna University revised curriculum on the part of inclusion of Tamil as a mandatory subject into the engineering courses, and that book was released in 2023 under the supervision of Dr. Muthukumar. There are many scholars doing work, and currently 6 scholars are working under him. His H&X is 11, and the number of citations he has received for his publications is 823 as on September 2025. On the part of his association with the various professional societies, he has been active member of Society of Automotive Engineers India, in which he is an annual member, and life member of Institution of Engineers, life member of Indian Society of Technical Education, life member of International Association of Engineers, and life member of Indian Society of Systems for Science and Engineering. So this is a very short introduction about him. And for the sake of audience, I would like to wait for one more minute and have a connection with Dr. Muthukumar here for having his initiation of the talks in the FDP.
Sir, good morning, sir. I have joined, sir. Already I have joined.
Yes, sir. Yes, sir. Have I read your profile completely, or should I read it, sir?
No, sir. No, sir. At the starting itself, I have joined, sir.
Thank you, sir. Thank you very much, sir. Thank you for making your commitment to join in this FDP.
Thank you, sir.
And you can proceed with the presentation, sir. You can take maximum.
Sir, shall we PPT, sir?
Yeah.
Yes, sir.
Yes, sir. Presentation is visible, sir.
Yes, sir. Okay, sir. Shall we start, sir? We should make it as a full screen view. 1 minute, sir. Make it a full screen view.
You can press the F5 button in your keyboard.
Yes. Adjustments. Is it visible, sir?
Clear, sir. Can you move to the next slide, sir, so that we see that progress?
Yes, sir. Just I will start with the initial starting slide, first slide, sir.
Okay, thank you, sir.
Good morning to all the participants. And before starting this session, I would like to thank the management of Welltech Multitech, Dr. Rangarajan, Dr. Sagandala Engineering College, Chennai, and Principal, sir, Head of the Department, Dr. Selvam, sir, and Professor S. Muthukumar, sir, and all the faculty members and participants. So I thank you all for your active participation and conducting this FDP. Actually, this green energy technology for sustainable development is a highly required one at present. So I am in the 10th session already. 9 sessions have been completed. So I am Dr. M. Muthukumar, professor and head of mechanical department and head of the fuel cell research lab in Nanda Engineering College. My topic is fuel cell technology for the green environment. So before we are talking about sustainability, we know that SDG goals. So SDG means Sustainable Development Goals. So what is sustainability? Simply, if you are telling, so we have to effectively use the resources, natural resources, and we should not deplete it, and we should keep it and save it for our future generations. So that is the aim of the sustainability. So in each and everything, they are insisting this to implement. So my seminar presentation is here, no poverty, no hunger, like this it is given. So my presentation is related to the clean energy and sustainable developments, the clean energy sources. And we are focusing, whenever we are conducting any program, we should match our programs related to this SDG. So that is highly required at present. So before going to this topic, we will know about fuel cell. What is meant by fuel cell? So because most of the guys may not know this fuel cell. Fuel cell is an electrochemical device that converts chemical energy directly into electrical energy and heat by combining hydrogen and oxygen without combustion. Okay, that is a major thing happening in this fuel cell. They operate continuously as long as fuel is supplied. So compared to battery, what is the difference between fuel cell and battery means? In fuel cell, we can continuously get the power, whereas in battery, only limited power, whatever it is stored, that will discharge. After that, we have to recharge this. So whereas in the fuel cell, whenever as like our IC engine fuel cell tank, if you are filling and we are supplying, it will continuously generate the electrical energy without emission. Then with zero emission, it is generating power with high efficiency. So that is the future of this fuel cell. Next, fuel cell technology. So fuel cell technology generates electricity directly from fuels, and it is known as green energy technology because there is no emission. So this fuel cell technology is called green energy technology. It acts as a versatile, reliable energy solution for transportation, stationary power, and storage, outperforming combustion engines in efficiency and reducing reliance on fossil fuels. So we know that nowadays one of the major problem we are for fossil fuels that are used for in IC engines, majorly used in IC engines and automobiles. For this, we are majorly depending on other countries. We are buying it from Russia, and we know that US opposed that, and they are asking us to buy it from their countries. So they are rising price, everything. So it will affect our economic growth and everything. It is affecting that. So we should reduce the reliance of the fossil fuels from other countries. We should generate our own fuel, or we should find out the alternate fuel for this. So this is one of the best solution for that problem. And this is a comparison of the fuel cell and IC engine. In IC engine, we know there are internal combustion engines that are using the petrol, diesel, or gases. In this, how we are getting electrical energy means, first fuel is whatever type of fuel, petrol, diesel, gas, kerosene, whatever may be, that is given to the engine. So the engine convert that chemical energy into mechanical energy by the rotation of the shaft. And then we are giving that mechanical energy to the genset, and then we are converting into electrical energy. So here, when you are converting from chemical energy to electrical energy, even in engine, there are so many losses happening. Heat loss, transmission losses are happening, and also one more drawback is emission. Emission is a major problem that we are facing with the IC engines. Nowadays, even we are increasing the emission rate reduction. Okay, still that is with the increasing of the number of vehicles, that emission is also increasing day by day. So whereas in fuel cell, the fuel majorly hydrogen and oxygen is used here. So fuel is given, when it is given to the fuel cell, it directly converting into electrical energy with maximum efficiency without noise emission. With high efficiency it is generating. So it is one of the major advantage of this fuel cell compared to IC engine. You will see one by one what is the efficiency and other things we will see in the forthcoming slides. So before that, you will see the working of fuel cell. This is a general electrochemical reaction is happening in this. So in this picture, so it is an electrochemical device. The left side is anode side where we are supplying hydrogen. Okay, pure hydrogen we are supplying 99.99% of pure hydrogen we are supplying, and the catalyst use this. This is a catalyst. We are using platinum mixed with the carbon. We are using as a catalyst, and right side we are using the oxygen. Okay, and right side also we have one catalyst. So these two are separated by the membrane. Okay, so proton exchange membrane. So when this hydrogen is from the left side, anode side, when it is contacting the catalyst, it is split into two components. One is 2H plus and 2 electrons. That is called hydrogen oxidation reaction is happening. That is a separation of electrons from the hydrogen is called hydrogen oxidation reaction. So that is happening in the anode side. So actually this membrane will allow only the positive things. That is a protons only. So the H plus only is passing from this left side to right side. That is anode side to cathode side. Whereas the electron cannot penetrate into this. So that is passing from left side to right side through the external circuit. See this, there is a bulb attachment is given. Actually some load is given, electrical load. So current is nothing but the flow of electrons. The electrons is passing from left side to right side. That is from anode to cathode, and it is reaching the cathode side. Cathode side, what is happening means, the cathode side we are supplying the oxygen of O2 plus the H plus from this membrane, and the electrons through the external circuit are combining. All these three are combining, and it is forming a H2O. 2H plus 2 electron is forming H2 plus of O2 is equal to O. So H2 is formed. So finally, we are getting in the cathode side, we are getting the pure water. Actually, it is a highly pure water. It is even, it can be used as a drinking water in space applications. Actually, in 1916 itself, in the spacecraft applications, they have used this fuel cells for generating the water. Water using this electrolysis process, they have generated the water, and they have used it for drinking purpose in space applications. So the overall reaction is H2 plus in the third equation, H2 plus of O2 is equal to H2O. Additionally, we are getting one more byproduct is the small amount of heat is generated due to the exothermic reaction. So three products we are getting. One is electricity, water, and small amount of heat. In case of this, is a single cell. So a single cell, there is one electrode, one membrane, and a cathode part is there. So this is called single cell. Suppose if we want to generate more power, we have to connect more number of cells. As like in our small battery, AA batteries that are used in our home appliances, we are connecting number of cells together. We are connecting in series and parallel. Okay. If you are connecting in series, that voltage will be increased, and if you are converting, that will be changed. Suppose if I want to change increase current or voltage, accordingly I can connect in series and parallel. When I am connecting this in series, the voltage is increased. Okay, whereas in connected in parallel, the current will increase. So as there is a general common principle of electrical engineering. So we are connecting and we are getting the required current and voltage based on the application where we are using this. So fuel cell types, mainly these are the main types of fuel cells. One is alkaline fuel cell, proton exchange membrane fuel cell, phosphoric acid fuel cell, molten carbonate fuel cell, solid oxide fuel cells. So out of this, based on the temperature, we are classifying these fuel cells. This PEMFC, DMFC is the direct methanol fuel cell, and alkaline fuel cell. These all are operating below 100 degree centigrade. So these all are called low temperature fuel cells. And the phosphoric acid fuel cell is operating at 200 degrees centigrade. It is medium temperature. Whereas the MCFC and SOFC are working at 650 and 1000 degrees centigrade respectively. So they are called high temperature fuel cells. So out of all these things, this PEM fuel cell, PEMFC, is having high efficiency of more than 80% theoretical percentage of efficiency it is having. So, and also highly reliable compared to others. So for portable applications, we are choosing this PEMFC. Whereas for stationary power generation, say as like our genset, what we are using in our industry and institutions, we are having diesel engine and generator. As like for stationary power generation, the solid oxide fuel cell is highly preferred. One more problem in using this is we should have high 1000 degrees centigrade. So that is difficult in doing it in the portable or transportation applications. So for most of the transportation applications, we are using PEMFC. The solid oxide fuel cells are used for stationary power generation applications. See, in addition, one more fuel cell is that there is a biofuel cell. Biofuel cells are eco-friendly electrochemical devices that use biocatalysts, especially enzymes or microorganisms. It convert biochemical energy from organic components like glucose, lactate, or waste directly into electrical energy. So, as like in our fuel cell hydrogen, we are using normal fuel cells, PEM fuel cells. Here, from the bacteria, we are keeping it in the anode side. So, using this electrochemical reactions, we are generating the electricity. So there are two types of biofuel cells. One is enzymatic biofuel cell (EBFCs) and microbial fuel cells. Utilize entire bacteria or microorganisms to break down organic matter, producing electricity while simultaneously treating water. So actually, there are some its efficiencies compared to other fuel cells. It is lower. So the use of this is a little bit limited. So we are going for the proton exchange membrane fuel cell and solid oxide fuel cells for most of the applications. And this is an exploded view of the PEM fuel cell. In this, the center part actually it is symmetrical. We know that what is symmetrical means the left and right side parts are same. Here the center part is MEA, membrane electrode assembly. So it is the heart of the fuel cell. It is consisting three components. One is membrane, and left side and right side it is coated with the catalyst layer. Actually, this black color. Why it is in black color? Actually, platinum is looking like a silver, but why it is in black color? Any guess? Please, if you have any doubt or clarification, please then and there you can clarify. Please unmute your phone and you can ask the question. Don't hesitate.
For more diffusion, sir? More diffusion of the atoms?
No, sir. Yeah, actually, there is a diffusion layer is two more layers in this next adjacent to that. Actually, the center part is the MEA. So after that, there is a gasket, the light yellow colored are two gaskets. Just like in our pressure cooker to avoid the release of the leakage of the gases, we are having this small layer of gaskets, and these two are gas diffusion layers. Actually, the real reason is thank you for at least telling the answer. Maybe right or wrong, but we have to interact. Thank you, sir. Sir, actually, the pure platinum is costly. We know that it is more than 2,000 rupees per gram. So pure platinum usage will increase the cost of the total component, total equipment. So in this case, we are mixing with carbon powder. So if you are using pure platinum, its efficiency is very, very high, but cost will also be very high. It cannot be affordable to us. So we are mixing with the carbon powder. So there is some limitations for this 40, 60. In this range, we can mix. When the platinum content is more, the performance will also be more. Actually, it is in the market in different mixing rate. It is available. So based on our applications and the requirement, we can purchase this. Accordingly, price will increase, price will change. So that is why it is in black color. And adjacent to that, or the center part is MEA. It consists of three layers, membrane and two catalyst layers. It is like a painting. Even the thickness of this all are very, very small, less than even if you are adding the 5 layers. it will be less than 1 mm. It is looking a bigger one, but it's a very small thickness it is having. And these were gas diffusion layers, the gray colored shape or gas diffusion layers. It is made up of carbon paper or carbon cloth. It is mainly used to make the gas to diffuse throughout the entire area of the membrane. Actually, this black color is in the catalyst layer is called active area because there is only the reaction is happening. So normally in our vehicles we are representing the capacity of the engine by cc. Cc means cubic centimeter. Now in a two-wheelers we are starting from 90 cc to 200 cc, 350 cc vehicles are even vehicles cars up to 1000 and above 1000 cc are available. So that is the internal volume, effective volume of the engine. Similarly here, this active area of this catalyst is they mainly contributing to the electrochemical reactions. So this active area is used to represent the size of this. Normally for testing purpose, we are using 5 centimeter length, 5 centimeter height of catalyst layer we are normally using. So that is only for testing purpose. Suppose if you want more power, we are connecting it in parallel. Normally the power produced is the product of the voltage and current. That is a power P is equal to voltage and current V into I in watts. In case of fuel cells, we are using power density. Power density means power generated per unit area of the active area, unit active area. So actually 5 centimeter and 5 centimeter means total area is 25 centimeter square. So per centimeter square, how much power is generated? That is called power density, because when we are comparing different sizes of the fuel cells, so common comparison factor is required. So for that, we are using this power density parameter. How much cc, as even in our engine, per cc how much power is generated. From that we can compare the engine performance, because the petrol engine, diesel engine, and different sizes it will vary. So efficiency we can compare like this. Here also we are using this method. And next to the gas diffusion layers on both left and right sides, there are two gaskets. The orange color are two gaskets. Next to that, there is a graphite plate that is called flow field plate. That flow field plate is made up of graphite, normally NCK 194 grade we are using. It is highly brittle material, as like our pencil tip. You know that the pencil tip is the made up of carbon. Is it brittle material or ductile material?
Very much brittle material, sir.
Brittle material, yes, sir. Very good. The brittle, it will break. It will withstand the load up to some level, and it will break suddenly. Whereas ductile material means it will bend, as like our TMT bars. It will bend. Finally, it will break. Okay. So whereas here it is made up of. Why we have to use this? Is there any specific reason for using this graphite plate? Means, so it is having high conductivity, and it is not affected by the moisture or water content in the cell. So how water or moisture is produced means one of the byproduct in this process is the water. So when we are using this, even we can use steels, special coated steels and other things. Even compared to all that, actually the handling is somewhat difficult, because highly brittle material, the making of the channels, actually you can see there is a curved shape is that is called a groove or flow channel. So that is used to distribute the gases, as like in our forms we are making a pathway to flow of the water. So like this, that then only it will cover all the plants. Suppose if you are opening in a plain area, only in the shortest path it will reach to the opponent path. So to cover the entire plants, we are making a pathway like that. Here also, to make entire flow of the gases to the catalyst layer, we are making this type of pathway. This is called flow channel. Actually, there are different types of flow channels are there. So here what they have given is the serpentine type of flow channel. So this is used to distribute the gases from outside to the catalyst layer or MEA. So both the left side and right side we are having this graphite plate. And next to that, there are two plates on left and right. So one is that is called current collector. It is made up of copper plate. Sometimes we are coating with the gold to conduct to increase the conductivity. Normally copper plate are used, and beyond that we are having end plates. You can see the right side and left side at the extreme corners. There are two plates, that is the called end plate. So the end plate is having the holes, so we are using the bolt and nuts. So similarly the opposite end plate is also having holes. So we are combining all. It is a stretched view or expanded view of the uh, fuel cell, single cell fuel cell. So we are combining all this and we are making it into a single component. By using bolt and nut, we are combining all these things. So while making this assembly, we should be take almost care. Even the tightening of the bolt and nut is also to be carried out using the some special torque range. So we have to set the depending upon the size of the fuel cell and the flow fill plate and components, we are setting the torque 5 Newton meter, 4 Newton meter, like this. We are setting the torque in the torque range, and we have to apply the torque uniformly in the all the areas. So also while assembling this, we should not tighten only on one side. We should uniformly tighten all the bolts from the starting to end. So first initially off of the tightening and then of all the bolts, and then 70% and then 100%. We should make this properly, otherwise there is a problem. Even the clamping, this is called clamping pressure. The clamping pressure of these components will also affect the performance. Suppose if you are pressing on only on one side or particular corner, the opposite there will be a gap. So one side fully compressed and the opposite side will be when we are compressing on one side, other side will be opened. So that will create the losses, even the flow of gases, flow of current, and flow of even water. So everything will be affected. So uniform tightening of the bolt and nuts are required. So now we'll see what are the benefits of PMMC. It is having high efficiency of 83% theoretically and 40 to 60% practical. Okay, it can be operated at 60 to 80 degrees centigrade, and quickly it can be started. Zero harmful emissions. There is no emissions from the this PEM fuel cell. Okay, whereas in solid oxide and molten carbon there will be small emissions, but whereas here there is no emission from PEM fuel cell. PMFC means proton exchange membrane fuel cell, and one more name is polymer electrolyte membrane fuel cell. Actually, one more thing I have left, that what are the materials in this used in this? Here the membrane it is like a thin paper, like transparent paper. Actually, it is made up of naphthalene. Its chemical name is polytetrafluoroethylene. And the catalyst is made up of next two layers made up of platinum plus carbon, and this carbon gas diffusion layer is made up of carbon cloth or carbon paper, and this end plates, flow fill plates are made up of graphite, and the current collectors are made up of copper plates, and the end plates we can use any material because they are not reacting with anything. There will be a insulator between this current collector and the end plate to avoid the connection of current from this current collector to the outer circuit. We are using this insulator between current collector and end plates. The end plates normally we are using aluminum or steel we can use, or even MS plate can be used. Just it is a support only. It should be properly. Even this bolt and nuts are highly insulated, because even the touching of this bolt nuts with any one of these components may lead to a power connection. So they are also highly insulated. This bolt and nuts are especially insulated materials are used. So this is a high power density. The power density I already told you, power generated per unit area of the active area. So it is having high power density, and we are using a solid polymer electrolyte. There is a thin layer, it is made up of solid. Whereas if you are using any liquid electrolyte, there is chance for leakages. So compared to that, it is using of this solid polymer electrolyte. That is called membrane Nafion. It's really safer and easy to handle. And scalable designs to any required size, we can make number of cells together, and we can form the stack. The assembly of single cells is called stack. So we can make it as a scalable one. For our requirement, we can design and we can fabricate the stack. Sorry. So silent operation. There is no moving parts in this equipment. So there is no noise. So it is very silent operation. Some modular construction, easy integration with the batteries and supercapacitors in hybrid energy systems. So suppose if you are combining with the batteries and supercapacitors, so we can easily integrate this fuel cell along with them. So that is one of the major advantage in any applications oriented. It is easy. Some component we cannot integrate easily. So one of the major advantages. This is also one of the major advantages. So just like a survey of number of vehicles in India, as of early 2026, the total number of registered motor vehicles in India is approximately 40 crore. Okay, so you know that our population is more than around 150 crores. Okay, the 40 crores, even the registered motor vehicles. Beyond this, many vehicles are also used, and which are to be replaced are also in the market. Actually, our Indian norms, according to our norms, for domestic purpose vehicles, so 15 years once we have to, first 15 years only we have to use without, after 15 years we have to get the fitness certificate. After that, every 5 years or 2 years we have to get the fitness certificate. Whereas in the commercial vehicles, road transport, that is a public vehicles, say every year they are getting FC. So these are they are making for the safety of the people, and otherwise what will happen? They will not do anything. They will continue running. That will lead to a lot of risk and accidents. So we are having 40 crores of registered vehicles. As like our population, this is also increasing year by year. So the EV adoption is little bit growing, but it is very less, accounting only 4% of the passenger vehicle market. So why we have to go for this EV and other green energy technologies? That is also why, because how many of us are having the e-vehicles? Even if you are taking one survey, even in our classroom or in general, if you take survey, if there are 100 people in our group or even our faculty members, only very few are having this electric vehicles. So there are some challenges in that also, and if there are solved, then definitely the people will go towards the e-vehicles. So now we will see what is the importance of fuel cell technology. As I have told you, in there are 40 crores of registered vehicles are in India. So even though the pollution and dependence of other countries for fossil fuels are the major problems in India, the India's automobile market is rapidly growing. So this is due to rising incomes. Actually, you know, we are in the fourth best economical range. We are growing fast. So our income is also increasing. So that is one of the reason for this type of increasing of this sales of the automobile industry. So urbanization, EV adoption, and some government policies significantly boosting employment, manufacturing strength, GDP contribution, and export potential. So these are the some major reasons for the growth of our automobile market. Even you know that recently the Ford has started in Chennai. They have started to they have started to produce the vehicles in Chennai factory. And also our CM has recently started the Tata automobile industry in Tamil Nadu. They have started to produce this shortly. That is a very big project, and more than 15,000 people will get the job opportunity through this. So even all are what will lead to means, so our Indian city, one of the Indian city is being one of the highly polluted city in the world. So we know that there is none other than our capital, that is New Delhi. So even though there are a few more big cities like Kolkata, Mumbai, and Chennai are there, but there is no such a pollution in these cities compared to New Delhi. Do you know what is the reason for that? The out of these four are major cities in India. So out of these four, even more or less the population and other things are majorly more or less nearly equal. But the Delhi is only highly polluted. What is the reason? Anybody knows?
So Bhuvanesh, you can unmute and ask questions. Already he has answered some of the questions in the chat box.
Oh,
The PM he has told us answers us.
so
He's asked about one installation, and he's telling like carbon black is used for better electric conductivity. The people typing in the chat box.
I open, sir. Bonus for the insulation. Bonus for the carbon black is used for better electric conductivity. Okay. There will be a 3 session.
That is my answer.
Oh, okay, sir. Yeah. Only one answer he posted, sir. Only one answer he posted. Carbon black is used for better conductivity.
Yes, sir.
Yes. Okay.
May I answer this question, sir?
Yes, sir. Yes, sir. Yes, sir.
The humidity in Delhi is not allowing the fog to escape, and it is becoming very hard to expel out this particulate matter.
Yes, sir.
So there is no net release in the particulate matter content. Actually, more and more particulate matter from smoke from the vehicles are building up, and that is becoming unmanageable even during
Yes,
these
sir.
Diwali days.
Yes, sir. Yes, sir.
Yes, sir.
So even they got banned to use this crackers. So even though in general days it is very the people are affected with the breathing problem, and definitely that will reduce the lifetime of the people in New Delhi. So even the government has announced to give the proposal for reducing this. Even the IITs and other are trying. Even the government is getting the assistance from the researchers and other persons to reduce this. So even anybody is working in this area, the pollution and other things, there is a good scope to apply proposal, and you can test, and you can try for that also. And one more thing, that is a correct, sir. One more thing, if you take other 3 cities, they are connected with the sea. So one area is highly free, and we are getting a free flow of air from the sea. So that is one more reason for the less pollution in these 3 cities, even Mumbai, Kolkata, and other Chennai. So it is near to the sea. So even we are getting free air from that. So that is one more reason for this. Whereas in New Delhi, it is totally surrounded by the land area. So even even outside people, it is agriculture people, they are burning their agriculture waste, and so many industries. So there is no cap or flow, easy flow of emissions from that area. So they are surrounding in that area only. That is also one of the major reason for that. So we have to find even the researchers, faculty members, even you can try in this area. Even the artificial rain also they have tried. I think it was not successful. The IITs, they have tried for artificial rain in this New Delhi, but that was not successfully reduced the emissions. So if anybody is working in that area, there is a very big scope there to get the funding and doing research in that area, because it is a highly required. Even in short area, even other cities also there, but we don't know about that range and other things. Even most of the cities, other cities also highly polluted only. So we all are, why I am telling this number of vehicles used and why it is increasing everything. Why I am telling all these things is, so when we are going towards this number of increasing of this automobiles, automatically the pollution is also increasing day by day. So we have to find out alternate solutions. We know that sustainability means effective utilization of the existing natural resources without depleting, and we should save it for our future generations. So that is one thing we have to keep it in mind, and we have to work. So this is the fuel cell technology, is one of the green energy technology. Here also some challenges and other things are there. Okay, so what is the importance of fuel cell technology? How it is uh, incorporating with our emission control. So we know that in 2030, India's EV policy focuses on achieving 30% of electric vehicle penetration by 2030. Okay, so government has to increase the subsidies, and they have to reduce the number of IC engine vehicles. Then only it is possible. Otherwise, it is very difficult. And so many research works are going on. Actually, one of the major problem in electric vehicles, after particular years, we have to replace the battery. Even 3 years or 5 years once, we have to replace. So those who are using the vehicle every day for 50 kilometers, 100 kilometers, that EV is highly, very useful, because that fuel cost will be very less. So for them, even in 3 years or 5 years, they can get back the some profit from this compared to IC engine. So for others, they are low range of running of the vehicles, running of the purpose or applications. It is really after 3 years. Actually, battery cost is more than 40 to 50% of the total cost of the vehicle. So they got, when they are replacing, so that is a major loss to the persons those are using that. So India's EV policy focuses on achieving 30% EV penetration by 2030. So here, if we have to make so many modifications in battery life, we have to focus on increasing the battery range and cost. Like this, so many researches are going on. Even the people can work on that also. And how the fuel cell technology is influencing in the importance to us is, we know that National Green Hydrogen Mission. So actually, it was launched in the 2023, Jan 4th, Jan 4th, 2023. Its aim is to make India a global hub for producing, using, and exporting green hydrogen. So we are talking about future fuel like this. So hydrogen is called as future fuel because from this we can generate the power with a very low emissions when we are using it in IC engines. So then why we are not using it nowadays? We have to make some modification in the existing system. Okay, even they are running the vehicles and even trains, and even on helicopter they have run using this hydrogen fuel. So there they are using engines. There the hydrogen is used as a fuel directly instead of petrol or diesel they are using. But when we are using this, we know that there are so many issues in using this hydrogen also. Okay, so we know that hydrogen is a very light material. So the handling of this or storing is the one of the major problem. Okay, storing we need a big size of tanks. Otherwise, we have to compress it to even 700 bar pressure, 350 to 700 bar pressure. We have to compress it and we have to store it in the tank. So it needs a huge amount of handling charges. And while using that also, we have to handle that very carefully, because you know that hydrogen is highly explosive. So even if there is any firing, it will lead to a huge problem. So we have to handle this very carefully. So if we are solving these two problems, the storing and handling problems, definitely this use of hydrogen in IC engines will lead to a very big change in our automobile industry. For that, we have to make, so there is a separate part. If I am taking, that will take a long time. So I am telling already, covering the basic things about this hydrogen storing and utilization problems. So if you are solving this, definitely that will also, the use of hydrogen in IC engines will lead to a very big inevitable and usable one in our market. Okay, so as like this, with a 19.744 rupees crore outlay, it targets 5 million metric ton annual production by 2030. That is our aim, to produce 5 MMT of hydrogen in the year of 2030, and abating 50 MMT of annual emissions. We are reducing it emissions and reducing fossil fuel imports by 1 lakh crore from the other countries. We are depending on for fuels. We are depending on now Russia, America, and Arabian countries. We are depending on. So we are spending a lot of money for that. Even if you take in our house, even we are paying, even a single home, we are paying single person per capita energy use will be around 1 liter throughout your per capita energy consumption of fuel. So if we are reducing this, definitely there's a betterment of for India. So we have to reduce that fossil fuel import, and that will create more than 6 lakh jobs to our people. Okay, so these are the benefits. So that will reduce the poverty in India. So as SDG, one of the first one is no hunger, no poverty. These two are main things. If whatever you do anything, first we know that basic 3 things: food, cloth, and some place to reside. Okay, so out of which first food is necessary. So in SDG they have keep that no poverty and no hunger as the prime importance. 1 and 2 they have given. So when we are increasing the job, definitely the people will get salary and they will get the food. So there is a major thing we can achieve in the SDG. So overall, the use of the fuel cell technology and other green energy technologies will strengthen India's leadership in sustainable and advanced mobility solutions. So this thing already we have discussed. The hydrogen is a future fuel. So in this, how we are generating hydrogen energy. Majorly, there are many things are there. Many methods are there to generate the hydrogen. Okay, so which method is majorly used to generate the hydrogen? Everybody knows how we are generating the hydrogen. Major production of hydrogen, which method is used?
From the methane, sir.
Yes, sir. Yes, sir. Very good. Very good. There is a method is called steam methane reforming method. Okay, more than 60 to 70%. More than that, we are producing the hydrogen from that only. So there we are using methane. It is naturally available. So that is majorly used that method is used to generate the hydrogen energy. So one more thing I told you, this is a electric hydrogen vehicle. Okay, there we can use 2 methods. We can use the hydrogen. One is in the engine. We can use the directly as hydrogen. Otherwise, we can use the fuel cells. The fuel cells, hydrogen is a major fuel. There we can use it to generate. For this, we need some tanks. We should store the tank. Even in our CNGs, in case of any accident, if it is exploded, that will create a problem. But it is not, that risk is very less in case of petrol or diesel engines. So this type of hydrogen, it is highly explosive. Even if we are storing, and we should have a very safety cylinders, and even the hoses and other controllers are very safety controllers and components are to be used. So how to avoid this? Suppose I am storing is a major problem in our vehicle. So how to avoid this problem? Any idea? Instead of storing it in the cylinders in the vehicle, how we can use this? So, okay, I tell you that can be generated in the vehicle itself using water, using electrolysis process. We can generate the hydrogen, and that hydrogen can be used in the engine or in fuel cell, whatever may be the energy generating system is there. You can generate this online and you can use this. And this is a lab facility available in our college. Actually, I have received the before that I would like to. So this is about our team and myself. So actually, I completed my PhD in the area of fuel cell in the year of 2016, and I have received the funding from ACT under RP scheme in the 2018 for 25 lakhs. And I have installed a fuel cell research lab in our college. Okay, from that only I have made so many patents and publications. Okay, and one utility patent received in the 2023. I have made one novel flow field plate. I already told you the flow field plate or graphite plates are used to distribute the gases in hydrogen and oxygen gases on anode and cathode side. So this plate I have incorporated on carbon insert that is mainly used for observing water. Actually, in the fuel cell, there are some challenges. Even if you take anything, there are some challenges. So that is why so many research works are going on to reduce it. So here, even though its cost is here, few more problems are also there. There is a thermal management and water management. So the water that is generated in the cathode side, if it is drained using outlet, there is no problem. Suppose if it is stagnated, then it will lead to a major problem in the fuel cell performance. It will block the flow of gases and it will not allow to react. So it will stop the reactions, and it will reduce the performance greatly. So in such a case, we must properly remove the water. For that, for that I told you there I have showed the serpentine flow field design. Like that, so many designs are there. Each and every design is having some advantages, some disadvantages, some power increasing, like that are there. So we have made small carbon insets in the flow path that absorb the water, excess water, and that has increased the performance. And for that we got the pattern, and also for more than four design patterns I got the new novel designs I have made and got design pattern. Okay, and more than 12 Web of Science papers published, and 13 Scopus papers related to this. In beyond this, I have published other things, and my H index is 12 and I index is 14. So now at present citation is 889. So during introductions are told, actually I gave that there is a old resume that as on September citations. Nowadays it is 889 number of citations, and one book is published, and I have received the best thesis award also. This about myself and my few achievements. In addition, recently in 2023, I have received funding from the MSME for developing fuel cell electric vehicle, and we are doing that project only at present. So these are some of the fuel cell lab set up in our college. Yeah. So this is a fuel cell test station in our college. It is 1000 watts to 750 to 1000 watts capacity, 5 volt, 150 amps, and temperature ranges up to 150 degrees centigrade, and humidity has 70 to 100 relative humidity I can maintain, and hydrogen oxygen flow we can use this. Here we are using 3 cylinders. One is the hydrogen is used. Everyone knows the use of that one, nitrogen. So anyways, I think they are posting in the chat box. Yes, it is in full screen. I could not see that one. Please wait.
No recent postings, sir. No problem.
Oh, just some indications I received. Okay, okay. Yes. One minute, sir. Sir, have you made the screenshot, sir? Have you taken a screenshot of this?
Only photos, sir, like
Yes, sir, yes,
entire
sir.
screen I'm taking. There is a
Yeah, yes,
recording
sir.
also available, sir.
Yes,
I
sir, yes,
can
sir, yes,
share
sir.
you
Okay, sir.
the Google Drive link also.
Yes, sir, yes, sir, yes. No problem, sir. Yeah. This is a fuel destination available in our system. Nitrogen, why I am using, we are using nitrogen means, actually nitrogen is called a purge gas. Actually, it is like a cleaning purpose we are using. So, doing experiment, we are passing hydrogen and oxygen, and after completing that experiment, while surround the system, we have to clean the gases in the pathway, because if that is acting in the system, actually see the right top, there's a single cell setup, there's an end plate, current collector and other things are there. So there is a hydrogen pathway, one is inlet, left side the blue color hose is the inlet of gas, and at the same at the bottom there's one hose, there's an outlet. Similarly, right side, this left side is anode, right side there are two hoses, one is inlet and other outlet. So when I am stopping the experiment or generating power, I have to clean the gases that are existing in the flow hoses and also inside the flow channels. Otherwise, what will happen? Even though it is stopped, the gases that are stored in the channels will continuously react, and that will degrade the performance of the membrane. Here, membrane is the consumable one. So after particular years, hours, we have to replace that one. So we have to clean that properly. For that purpose, we are using the nitrogen. So nitrogen is a purge gas, and the left bottom we are having hot pressing machine. It is having a 15-ton capacity and 192 kg per centimeter square pressure can be applied, and 200 degrees Celsius of heat. We are separately buying this membrane and GDE with the catalyst layers. Membrane, so these three are made as a single component. We are sandwiching this as a heart of the fuel cell, and this is a 100 watts stack with horizon fuel cell store. Its cost is around 1.5 lakhs, and this is a controller. These controllers are used for controlling the gases from the cylinders. Actually, this is a stack consisting of 20 cells. Actually, if you zoom it, we can see there are 20 cells are combined together. So this is a tailor made. Even we can make that the performance and assembling are not up to the level if we make ourselves. So we have purchased from the outside. And normally the console and ANSI software are used for this purpose. And this innovation, we have made a small fuel cell electric vehicles, and we have tested. And the left bottom you can see this is the innovative model we have made, and this is a fuel cell car diagram of this. Actually, instead of engine, we are replacing it with the fuel cell stack. And instead of fuel tank, we are using petrol or diesel tank. We are having a hydrogen tank, and from that it is power is fuel is supplied to the cylinder. So there is no need of keeping a separate oxygen cylinders. Why? Means From the air itself we are taking the oxygen. How much percentage of oxygen is in the air? It is approximately 21 percentage. 21 percentage of oxygen is in the air. So we are taking the direct air instead of the tank. We are taking air, and that is used as a instead of oxygen. But 5 times more amount of quantity of oxygen air is to be used, because only 1/5 of the percentage of oxygen is in the air. And these are the commercial vehicles available in the market. Fuel cell electric vehicles, majorly the Toyota and Honda. The Toyota model name is Mirai. It was launched in 2014, and this is a 2016 Clarity fuel cell. Seating capacity 4 and 5. So dimensions and these are given. So type of fuel cell and capacity power are given. The first one, Mirai, is using polymer electrolyte. Both are using polymer electrolyte. The power capacity is for Mirai 114 kilowatts, whereas this Honda Clarity 103 kilowatts. Battery they used nickel metal lithium ion they are using. So fuel used is 70 megapascal compressed hydrogen in 2 hydrogen tanks, and that is also 70 megapascal compressed in 2 cylinders. The driving range, suppose using this cylinder, if it is filled, we can go up to 650 kilometers in the first one, and 70 kilometers in the second Clarity vehicle. Okay. Within 3 minutes, and we can refill the hydrogen, just like our gas filling in the CNG and LPG nowadays we are using. So like this, within 3 minutes we can refuel this tank, and we can continue our journey. So this is the India's first hydrogen fuel cell powered bus, developed by Tata and IOC, Indian Oil Corporation, in the month of 2018. In this system, the fuel cells are kept over the top. The top, they are having the cylinders, hydrogen cylinders at the top. So there is first bus in India, hydrogen bus, fuel cell bus. Actually, the time is I am ready to clarify your doubts. And actually, now 6 people are research scholars are working on this area in different areas. The fuel cells, battery, and thermal management, water management, like that. The people are working in this area, and they are also developing a new profile plates designs, and we are applying for the pattern also. So it's a major one thing. Everyone will focus on this SDG. Okay, because if you do any activities, please focus with this. I want to share one thing about telling this. Last 2 days before, we have visited the GSW in Salem, near to Salem. There is a JSW steel plant is there. This is one of the biggest plant. They are making more than 890 different grades of alloy steels. It is one of the biggest integrated steel plant. And what is the main features? These are their capacity and other things. So what they are doing is, so they are not wasting anything, and they are not emitting any wastewater to the outside. More than 67% of the heat power generation, they are using coal, coal they are generating. For this steam, more than steam out of 100% of steam, 67% of steam is produced from the waste heat of the plant. So they are recovering all the in all the places they are having heat recovery system, and they are generating power So 67% of that heat, steam heat is generated from this waste heat only. Similarly, even they are recycling, even the furnace slag. So they are also effectively utilized, and they are taking heat, and they are removing the iron particles from that, and they are making some fire block for their own use. So like that, so mostly they are reusing this wastages effectively. So that is the main thing for our sustainability. So we should effectively use the resources, and we should not make it to deplete, because for our future generations it is necessary. Even when we are using this future, what will happen means the water scarcity will increase, or water more water will be generated. There is one question in future. Suppose if it is you like this, what will happen? Water scarcity will happen, or more water will be generated. Na? There's more water will be generated, because so we are emitting more greenhouse gases. For that, we are for generating power. Suppose even if we are pumping a water from our boat to tank, we are using the some electrical energy. That electrical energy is mostly in India. More than 70% of electrical energy is generated from the thermal power plant. Thermal power plant means we are using coal. By burning a coal, we are generating the power, and that is used for used in most of our area. So for that by burning of the coal, that is also emitting the gases, that is polluting the environment. Okay, so that is lead to the global warming. When global warming is increasing, so that will melt the iceberg. Even in the Arctic and Antarctic, that is melting. Okay, even in future, there is a sudden rise of the temperature. Overall temperature will be raised from 1.5 degrees Celsius to 2 degrees Celsius. Even this value is very less. When it is average, means automatically in some area it will be more, some area it will be less. So even India is a very hot country, so that will lead to a very big problem. So that will create so many problems to us. So average only 1.5 to 2 degrees Celsius. For our areas, it may be more, maybe 3 or 4 degrees Celsius will be increased. So that creates so many diseases and other problems to us. And we will use some other alternatives. We will use the AC. For AC, running AC, we need a power supply. For that, we will run more, burn more number of tons of coals, and more number of emissions will be there. Again and again, it will spoil our life. So please, not only this one, wherever possible, please make the natural resources effectively. Okay, that is required for even our generations. That is required. We should keep them for our generations. So that is the things I have learned. We have learned from JSW. So they have made visit and other things. Finally, they have told all the sustainable practices they are doing in their company. So if you are everyone, it is make it as a habit to use these sources effectively without wasting them. If you make it even for our children and our students, if you make it as their habit, then definitely future will be very happiest one.
Sir,
Yes, sir.
morning. Sir, morning.
Yes, sir. Good morning, sir.
This is Karthikeyan, a participant.
Yes, sir.
And sir, I have a question.
Yes, sir. Yes, sir.
What is the smallest size that can be possible for making a fuel cell, and how much volt it can generate? Suppose if you see the electric battery,
Yes,
we
sir.
have these 1.5 volt batteries. This that can be connected in series to bring out a higher voltage.
Yes, sir. Yes, sir. Yes, sir.
Similarly, what is the smallest size we can make
Sir,
in the fuel cell?
actually, 3 centimeter and 3 centimeter. Actually, these all are customized ones, sir. When you
Okay.
are going smaller sizes, we have to do it very carefully. Normally, for testing purpose, we are making 5 centimeter into 5 centimeter in all the research purpose. commonly throughout the world they are making.
How much is
Even that will
produced there?
generate, sir, per centimeter,
Yeah.
maximum power generation is 1 watts per centimeter square is achieved.
One
1
watt
watts
per
per centimeter
centimeter
square.
square.
Per centimeter square, sir. Even
What
5
is the
centimeter in
voltage
5
there?
centimeter.
Voltage output? Voltage output.
Voltage output, actually, open circuit voltage is 1.23 volt. So when we
Okay.
are connecting, that is a theoretical one.
Okay.
Normally it will be around 0.9 volts, sir. 0.9 volt, even from 0.3 to 0.9 volt. When you are connecting load, automatically it will be reduced. So normally at 0.5 to zero point 0.6 voltages, we can get maximum power.
Okay.
Maximum power from the fuel cell. Its OCV is 0.9 volt. When we are connecting, automatically its voltage will be decreased.
0.6.
So normally 0.5 to zero point 0.6 voltage at the range,
Okay.
the fuel cell will give maximum power. At that time, the current multiplication of this voltage and current gives the power. So that will be increased. Suppose if I want to work out at higher voltage, that power will be little bit changed. So
Okay.
actually, it is following. There are two curves are there. Power density curve and polarization curve. I have not added this curves in this. From that, we can easily understand how much. Suppose if I need more voltage or more current, I can connect series and parallel.
Okay.
Suppose
Okay.
if I want more voltage, means I have to connect the single cells into series, or otherwise I can increase the active area. Even 100 by 100 mm, 10 centimeter into 10 centimeter, or biggest is 150 into 150 centimeter. Actually, why we are using centimeter means as like our IC engine. Even though we are SI unit is meter or mm, we are
Mhm.
engine capacity is represented by cc. The
Okay.
cubic centimeter, that is centimeter cube. Here also we are using the centimeter for area representation. So if we actually we have tried up to 3 centimeter into 3 centimeter plate. So if we make beyond that one, it will be, there is no use because power generation will be very less, sir.
Okay, sir. Okay. Sir,
And
have you
some challenges are also in this fuel cell also. I am telling one of the thing, some challenges also I have to tell. One is
Mhm.
the thing we have to use and store that gases properly, and the cost of the components is also a little bit high. So
Mhm.
so many research are going on to reduce that also. As like EV, battery and other components. Here also so many research works are going on. But in India, the number of active participants are less because we need fund for doing the things. So that is one of the some problem in the fuel cell technology, sir. But if it is successfully implemented, it is also modified version of electric vehicle. Fuel cell electric vehicles are modified version or next version of the electric vehicle. So if you are doing that one, definitely we can run the vehicle for long range, because even battery for particular range only we can run. Again, we have to recharge and we have to run it. So it will take time for charging. It will take some time. If you are having this system, we can run the system without stopping. We can continuously generate by using this hydrogen and oxygen. And fueling and refueling is also very easy, just like our commercial IC engine vehicles.
Sir, is there any commercial implementation already there anywhere in the world?
No, it's not in India, sir, but in even in US and UK, the fuel cell cars are available.
Okay.
But India, this Hyundai, I don't know. Few companies are trying Hyundai. No, not in this one minute, sir.
But considering its size, it can be implemented in railways. Am I right, sir?
Yes, sir. Yes, sir.
Better than domestic.
Ships they have tried. Cost wise, it is higher, sir. That is a major problem.
Okay.
So these are the leading companies developing fuel cell electric vehicles, sir. Tata Motors, Ashok Leyland, Hyundai, Toyota, and Mahindra and Mahindra. These are developing the fuel cell electric vehicles in India, but they are not released yet. But still, they are in the research level and development, sir.
Okay. But I feel it is best suited for these large transport vehicles like railways, goods
Yes, sir.
carriers.
Yes, sir. Yes, sir. Yes, sir.
Yes, sir. Okay. Thank you, sir. Thank you. Thank you very much.
Thank you for the active question session, sir. Out of these 6 days, today's session was very, very interactive. Any more questions from the audience? Unmuting from your mic will help the speaker to better understand your question.
Actually, here I have given the overall view only, not to go. I didn't go in depth because it's a new area. I have given overall view only. Actually, general statistics, why we have to go like that only. I have given. If any doubt in technical part, you can contact me. So you can note down my mail ID. Muthu PhD 2010@gmail.com, or my contact number 98659 You may contact me through WhatsApp or mail. Phone, if I go to college, will be very busy. So if you mail, I will reply you. Or send the WhatsApp message. I definitely will reply you if you have any doubt in this.
I think there won't be any
wants
questions.
to visit our lab, if anybody is near to E-Road or crossing this area, you may come and visit our lab.
Visiting the lab in the office, sir.
Actually, very few colleges are having this facility. We are also BIT also after actually I did my PhD in PhD. Yes, sir. Yes, sir.
Sir, as you mentioned now, you happen to visit the Taifa Core Technology Center, where this fuel cell
testing
setups are there.
cylinders, and we have.
So any workshops you are planning, sir?
Okay, sir. Actually, this is in our lab, sir. It is in our college. Sir, actually, we have also planned for that because this semester so many programs are coming in our college also. We have planned only in the month of June, May and June, sir. Actually, that time only the faculty will be free. We have planned for offline FDP, sir. Even if you have a doubt, if you want to willing, you can come and visit our lab, sir. Please inform us at advance. We have planned for 1 or 2 days seminar and other things, but conducting is one of the major problem. Time. If it is offline, it is very, very useful. But even our faculty is also very busy. Among all this, getting arriving is somewhat difficult. We are also planning for that also, sir.
Sure, sir. Sure, sir. I'll be very happy to meet you in person. And
welcome, sir.
Yes, sir. You have taken up to the extent of the time allotted to you. But even if now any questions are there, any clarifications are there, you can make to your speaker. Otherwise, we can go to the conclusion part. Audience, any more questions? Okay.
So once again, I thank your management, principal, head of the department, and Professor Muthukumar sir for giving me this opportunity to deliver to take part in this 6 days FDP. Thank you very much, sir.
Yes. This is my duty to thank the speaker because he has given a nutshell.
If there is any queries, we will conclude this session, sir.
Yes, sir. Yes, sir. Am I audible, sir? Clearly?
Sir, sorry to interrupt. One last question.
Please, please.
Yes, sir. Audible.
Yes, sir.
Yes, sir.
What would be the cost required to make a small setup in a laboratory, sir, as you did for your experiments?
So small setup. Actually, here the controls definitely it will take 5 to 10 lakhs. It is required, sir, because even the controllers are a little bit costly, sir. Even the controllers for flow controllers for gases, even they are a little bit costly. Even a single controller comes around 1.5 lakhs. For hydrogen and oxygen, if you have, that is only leading to 3 lakhs. Other
Okay.
small component and single cell, it is coming around 50,000 to 1 lakh, we can make it, sir. But the other setups, what we are having is difficult. That is why I showed you on 100 watts fuel cell test station. Sir,
Okay.
not test stations, stack. Even its cost is 1.5 lakhs, and the controller itself around 75,000, sir. The controller for that is a small controller that is converting used for both hydrogen and oxygen,
Okay.
because we cannot directly use the hydrogen and oxygen to this system. We have to control, we have to use the humidify this, and we need to heat it, and these two are required, and required amount of gases, mass flow rate also required. These three are to be majorly controlled: the pressure, temperature, mass flow rate, and additionally humidity. So these
Moreover, the
four are to be.
instrumentation. Moreover, the instrumentations to measure all these things.
Sir, yes, sir.
Moreover, we need the instrumentations to measure these things, various variables.
Yes, sir.
So that also may cost more, like measuring how to measure
Yes, sir.
mass flow.
Actually, it is a test level. Suppose in the implementation level, we are testing purpose. Because we are different operating conditions, we are testing. If we find the best one, accordingly we can set a specific applications. We can set and use it, sir.
Yes,
Actually,
sir.
this is actually we need that type of setup, because during research level, we only one specific application is not enough. We have to test it in different temperature, various operating conditions.
Yes.
So then only we can find the best one, and we can apply for that. So definitely it is coming around 5 to 10 lakhs. Actually, we have purchased from Chennai only, from K-PAS Instanic Engineers. Actually, this fuel cell cost is around 19 lakhs, sir. Up to 1000 watts we can measure. 150 amps to 1000 watts we can measure this. Even small setup, it will definitely take 5 to 10 lakhs. It will be required, sir. It is required.
Okay.
Even
Thank
you
you.
can contact them for other things. And also the one more fuel cell store is that the Anabond fuel cell store is in Chennai.
Okay.
Actually, they are locally available in Chennai.
Okay.
Even you can contact them. There is a person, Mr. Dr. Valaidam. You can contact them. You can get the quotation for that also. Even in sir, in your website also you can refer fuel cell store and or Horizon. So these are the websites. They are suppliers. They are supplying. But when you are purchasing from them, you have to import from foreign countries. So that will lead to some more additional costs. You can check it in the website also, sir. Horizon and fuel cell store.
So, okay. Thank you, sir. Thank you. Thank you for valuable information.
Welcome, sir. Thank you. So I think one more session is at 11:30, sir. Sir, I think
No,
people
yes.
are waiting for one more session.
Yes, sir. Yes, sir. That session will be rescheduled because your answering and interaction is very good, sir. No problem. We reschedule by another half an hour, and it is not an issue. It is
Actually, time 11 to 10 to 11:30 it was given. That is why.
Yes, sir. You
Yeah,
you
delay,
have
sir.
stick to your time schedule.
Okay, sir.
Now, to make the audience have a small break, it is my duty to give you a farewell, and I hope we will meet in person, because whatever concepts you have given
Yes, sir.
regarding solar, the fuel cell based green energy
Yes, sir.
technologies, they are going to try it at your home. Like our last audience, he has asked a number of questions. Like he has got into a curiosity, like how I can set up a lab like you, sir. That is the kind of impact
Yes.
you have made into the audience.
Yes, sir.
So
Thank you.
at
Thank you.
least I have seen in Amazon like stores, some kits are available for, like that will make solar green energy like that. It is available, and I visited
Sir,
VIP.
actually, one more thing.
Yeah.
Yes, sir. Just one, sir. Actually, that tailor-made components we cannot dismantle, sir. Actually, we can use as it is. and we can get the output. Suppose if you want to make any changes, it is not possible. Only the operating parameters within their limit we can make. Actually, one of the major components inside that we cannot make any modification. So it is like a battery. We can use it and we can get output. Give input and get limited output. We cannot make any research level work in this. So that is a problem. Suppose if we make it ourselves, that is also a tedious one. We cannot make it easily, and also performance will not be up to that level. So if we if we are purchasing it, we can just use it for any particular applications. Up to some level test only we can do it. That is a problem, sir.
And one more suggestion from my end, sir. School
Yes, sir.
students or students in the STEM stream, they should be given a workshop and hands-on, so that they try with their like concept level posters. So they create a knowledge in the early stages. That will somehow make them stream towards this sustainable way of green energy in the basis of green hydrogen-based green energy technologies.
But one more thing, when we are giving to the school students, they should be very, very careful in handling this hydrogen. In case of anything, firing or something, they should be able to handle that one. So under the supervision of any one person or mentor, we can assign the work, sir. Otherwise, even that is one of the problem here. We cannot give it to normal students. Otherwise, I have to sit there and I have to monitor carefully. In case of any emergency, I go, because it's a testing. We are testing it different operating parameters and conditions and with components. So that is also here when research level. If it any problem, others it will break only. It will not harmful to others. But here we must be very careful when doing research work, sir. So if we are assigning to the school students or anything, anybody's, even my research scholars, I will insist them
Okay.
about the safety first, and research is only. We have to take all the safety measures before doing any research work.
Sure, sir. Sure, sir. We'll take up your advice, and we'll always
Yes, sir.
give safety instructions. And we are very thankful to you, sir. We'll close the session now, but we'll expect one more session from you.
Thank you.
Thank you. Thank you, sir. Thank you very much, sir.
Okay, sir. Thank you. Welcome,
Thank
sir.
you.
Welcome, sir.
Audience, please stay tuned because the session will stop now, but the session will again be started at a delayed time, 1:30. We'll have a different session on the hydrogen technologies, like wind energy technology, and then we can go to a winding up session with the last speaker in the 12th session. The 12th session may happen at 3 p.m. So we'll have a break in the morning. We'll join after lunch in the afternoon. That will help you to take a very healthy break in the weekend. So we'll join by 1:30. 1:15 we will expect everyone to have your attention in the screen. So till then you can keep logged in, no issues. We'll keep telecasting this.